Before we delve into the next module, I want to do one more ALEKS worksheet. I think this one is called Area and Perimeter of Quadrilaterals. So, when we dealt with the rectangle, we said that the area of the rectangle was length times width. So, length times width. And then we used that to find the area of a triangle. If I had a triangle and I wanted its area, we decided that if we take what we call the base, so area equals base times, and then the height. And sometimes the height was a side of the triangle, but most of the time it's not. The only time the height will be a side length of the triangle is when you're dealing with a right triangle. If I had a right triangle, this could be the base and this could be the height. But most of the time that doesn't happen. So we decided that the area of this triangle is simply the area of the rectangle, and we notice that this triangle and this triangle are the same size, and this triangle and this triangle are the same size. So the area is base times height divided by 2. 1/2 base times height. Okay? So we have some other figures that we need to look at: rhombi, parallelograms, trapezoids, and kites. And we need to find the areas of those. So if I had a parallelogram, and I wanted to know the area of that, well, if I cut this triangle off and I slide it over, it will fit right here. And I end up with this rectangle. And this is the length and this is the width. And you'll notice that that length is the original base. Now, this is kind of weird, but the top and the bottom of a parallelogram are both called bases, which is a little strange. So you have like the top base and the bottom base. And the length of the black rectangle is exactly the same as the base of the red parallelogram. And then the width of the rectangle is equal to the height of the parallelogram. So the area of a parallelogram is simply base times height. And just like triangles, the height is not necessarily one of the sides. In fact, most of the time, the height will not be one of the sides. So it's the base of the parallelogram multiplied by how tall the parallelogram is. Uh-oh, he's on his phone. Are they good looking? No? Well, that wasn't worth it. Well, you just take what you can get. Is that fair? Some of us have to settle. All right. What about a rhombus? Well, a rhombus is just a parallelogram where all the sides are equal. So the area of a rhombus is still going to be base times height for the same reason that a parallelogram was base times height. So the area of a parallelogram, that formula transfers over into the area of a rhombus because all rhombi are parallelograms. Okay, the last one is a trapezoid. Oh no, this isn't the last one. So how do we do a trapezoid? Well, in a trapezoid, we have what we call base 1, which is the top, and then base 2, which is the bottom. And we want to know what is the area of this trapezoid if we know the two bases, and we also know the height. Well, if I draw a rectangle around this, it's obvious that that rectangle is larger than the trapezoid. So that's not going to work. We're going to do something a little bit tricky. I'm going to take the midpoint of this side and the midpoint of this side, and I'm going to draw a rectangle that goes through those points. Okay? And now hopefully you see that this triangle can be flipped up and put there, and this triangle can be flipped up and put there, and then we get this rectangle right here. And that rectangle has the exact same area as the original trapezoid. But the question is, what is the width? What is the base of that rectangle? The height is easy. The height has not changed. So this distance is still the same. So the area of a trapezoid is something times the height. Can anybody figure out a way to determine how big that is? But what if I put numbers to it? What if I said that base 1 was 8 and base 2 was 12? How big is the base of the rectangle going to be? Anybody figure that out? Well, let's look at a couple things. So this length here is equal to, let's do it this way. This length here is equal to this length here. And this length here is equal to this length here. So we're going to take half of this piece and half of this piece, and it turns out the new base, which is this distance right here. So I'm running out of colors, sorry. So this is 8, and this is 12, but this right here has to be in the exact middle of 8 and 12. So it's the average of the 8 and the 12, which would be 10. So the area formula for a trapezoid is base 1 plus base 2 divided by 2 times h. So to find the area of a trapezoid, you look at how big is the top, how big is the bottom, and then calculate the average of those two. Add the top and the bottom together and divide by 2. And that number will be the base of the rectangle that's equal in area to that of the trapezoid. And then you just multiply that by the height. So in this case, if the height was 3, we would do 12 plus 8 over 2 and times that by 3. 12 plus 8 is 20. 20 divided by 2 is 10. 10 times 3 would be 30. All right, last one. What about a kite? So in a kite, these two edges are the same length, and these two edges are the same length. So how do we find the area of the kite? Well, it's actually pretty simple. We're just going to cut it into 2 triangles. And then over here we have a rectangle, and over here we have a rectangle. And there are a couple different ways to think about this. You could treat this as one big rectangle, find the area, and then divide by 2. Right? That's one way to look at it. The other is, if I cut this triangle into pieces, this triangle could fill that space, and this triangle could fill that space. So the area of the kite is going to be equal to the area of this rectangle. So you either find the area of the big rectangle and divide it by 2, or you find the area of one of those side rectangles. And each of those measurements will be equal to the area of the kite. Does that make sense? All right, let's pull up our assignment. Maybe. Looks like I don't have it ready. Sorry. All right. So the assignment is called Area and Perimeter of Quadrilaterals. And we'll start off with a parallelogram. So the area of the parallelogram is going to be base times height, because that rectangle right there is equal to in size to the parallelogram. So the area is equal to 11 meters times 9 meters, which is 99 meters squared. All right? All right. So here we want the perimeter of a trapezoid. And the trapezoid has vertices 5, 1, negative 5, 1, negative 2, negative 4, and negative 5, negative 4. I think I did that right. 5, 1, negative 5, 1, negative 2, negative 4, negative 5, 4. Okay. So this side is a 5, this side is a 3, this side is a 10, and I need to know what x is. So I'm going to draw a right triangle right here. And in my right triangle, I have a 5 and a 7 and an x. So 5 squared plus 7 squared equals x squared. That's 25 plus 49. So that is 74. 2 and 37. Okay. So I take the square root and I get x equals the square root of 74. Now, notice it wants an exact answer, not the decimal. So this is going to be a little strange. But how far would I travel if I walked all the way around the perimeter? Well, that would be 3 plus 5 is 8 plus 10 is 18 plus the square root of 74. And it doesn't want the decimal answer, so we're just going to leave it like that. 18 plus the square root of 74. You do have to check, does 74 simplify? Well, that would be 2 and 37, and 37 is prime, so that one does not simplify. Okay, number 3. All right, area of the parallelogram. So we just need a rectangle. The base of that rectangle goes from negative 4 on the x to 3, which is 7. The height of the rectangle is from negative 9 to negative 5, which is 4. So the area of the parallelogram is just 4 times 7. All right. Okay, trapezoid. Area of a trapezoid is base 1 plus base 2 over 2 times the height. Now this trapezoid is turned on its side. So this is base 1, and this is base 2, and then there is h. So 7 plus 19 over 2 times 4. 7 plus 19 is 26. 26 divided by 2 is 13. 13 times 4 is 52 yards squared. Right. And this is the last type of problem. Wait a minute. Okay. So, for the rhombus, I know that AC, this is 26, and this is 16. Okay, so I need to know what is the height. Well, what is the base, and then what is the height. So with a rhombus, you're going to have a right angle right there. So this is going to be 8, and this is going to be 13. Half of 26 and half of 16. Okay, so I'm going to draw my triangle like this. Nope, sorry, I drew that wrong. Well, I'll just draw it as it is. So 13, 8, and x. So 13 squared plus 8 squared equals x squared. So that's 169 plus 18. What is that? Plus, not 18, plus 64 is 233. And we take the square root. Did I do that right? 8. I guess so. Anyway, so this is the square root of 233. Okay. I don't like this problem. I think this is harder than this class is supposed to be. Okay, I'm going to yank that one out. Let's just make sure there isn't another one. Okay. Yeah, I'm going to go through and remove those. And, okay, this one we can do. All right. So this rhombus, this piece can go here, and this piece can go here. So all I need to know is this length times this length. So from -2 to 6, the base is 8. And from -2 to -6 is 4. So the area of this rhombus is 8 times 4, which is 32 square units. Okay, that's it. I'll go in and fix those. Get to work.